So this session is on SetBuilder and interval notation. This is something that is used when we talk about domain and range. It's used when we talk about solving linear inequalities, and you're going to see it a lot if you have to go on to college algebra or calculus or other types of math classes. So this is sort of getting you into that kind of thing. So just to start to review what we call inequality symbols. So inequality meaning they're not equal signs, they're other than that. So we've got the less than or equal to, greater than, and greater than or equal to. And basically, we always read these left to right. And the bigger number is always on the part that's open. So you've got like the point of your little arrow thing, and that's always indicating the smaller number, and then the open is the bigger number. So when we have 2 and then it opens to the right 5, that's 2 is less than 5. That's how we read that out loud. So we talk about linear inequalities, and when we have linear equations, there's no exponents on the variables. So linear inequality also has no exponents on the variables, but we just, instead of an equal sign, we use the inequality symbol. So all of these inequalities you're seeing on this chart, these are all considered linear inequalities because the variable x doesn't have an exponent on it. And we've got two categories basically where you have one inequality symbol, and then on the right you have two inequality symbols with each one. These are called compound inequalities, and these are basically indicating that your number is in between two numbers rather than it's smaller than or to the left or to the right of the number. So on the left it's usually your number is less than or your number is greater than. On the right we're looking at our number is in between. So I'm going to just write that down. Maybe I'll just use parentheses. That's what the compound inequality means, is that it's in between two other numbers. So when we have these types of things, we're graphing them and then we write their solutions. And graphing is very helpful in order to write the solution. We can't just, our solution isn't just a single number, because we're saying that, oh, x is less than like 5. There's lots of numbers that are less than 5. So we can't just write a single number. So we use a graph to represent the solutions to show where on a number line our answers are, or we'll use SetBuilder or interval notation, which is what I'm going to be focusing on today. But the key thing is what the symbols mean. And so this part, this is really important. So if we have a less than or a greater than symbol, so it's the little arrow without the line underneath, that means that our end point is not included, is not an answer. So if we say that our solution is less than 5, 5 is not part of those solutions. And when we're writing our solutions, we usually use parentheses or open circles. And an open circle will look kind of like that. And that's also when we're graphing. So when you graph, you might have a parenthesis on your number line or an open circle to indicate that that point is not included. If you have the less than or greater than with the line underneath, meaning that it's also equal to, then if we say it's less than or equal to 5, 5 is also part of the solution. So our end point there is included. And when we graph or when we write a solution, we'll use brackets. Or specifically on the graph, we use a closed circle that looks like that. So those are important to note the symbol, and then what's, the inequality symbol, and then whether it's a parenthesis or bracket. That's really important because that's the key to interval notation. Interval notation uses parentheses and brackets. But we'll start with SetBuilder notation because that's the easiest type of notation. So it's good to know, when it says SetBuilder notation, you need to know what it means. And so we've got this form where you have a curly brace, and then you've got your variable, So I'll highlight here, you got your variable. You have a vertical line, which is basically half of an inequality, or half of an absolute value, but it's a vertical line. And then you have your inequality, whatever your x less than 5 or whatever it is there. And then you close it with curly braces. So an example here is we've got the curly brace, x, the vertical bar, and then x greater than or equal to 2. So we read this out loud. We've got the curly brace, which means set. So we have the set of, that curly brace is telling us we have a set. And then our variable, all x. And then the vertical bar is read out loud as such that. Or I will, instead of such that, I'll use the word where. And then you have your inequality, x is greater than or equal to 2. So that's how this is read. We read it left to right, and you'll get some inequality, and you just kind of pop it into that form. Because whatever your inequality is, you just put it on the right side. Everything on the left looks the same, and you've got this curly brace. So SetBuilder notation is pretty simple because you were given an inequality, you just kind of pop it in. Interval notation is trickier, but this is actually more commonly used these days. When I was learning algebra, we didn't really use interval notation, and now it's very common. So it's really kind of switched over from, we used to use SetBuilder, and now we're using interval notation a lot. And it often looks like an ordered pair. An example of interval notation might be something like this. So it kind of looks like an ordered pair, but the symbols are slightly different. And we create interval notation by reading the graph. So I always recommend graphing before you create interval notation, because the graph will tell you what your interval notation looks like. We always write things from left to right. So our smaller number is always on the left, and then we always have a comma, and then the larger thing is on the right. We use parentheses for those endpoints. I talked about that, the less than or greater than. We use brackets if we have a less than or equal to or greater than or equal to. And then if you have infinity or negative infinity, we always use parentheses. So what's much more helpful is this. So this is something that you're going to want to like print out or copy down after I email this out, because this will be your cheat sheet, so that you have your inequality on the left, and then it tells you what does it look like in SetBuilder, what would that look like on the graph, and then what does it look like for interval notation. So I've filled in the graphs for these, and I'm going to demonstrate the interval notation part. So let's look at the top one. So we have x less than a, and a is just some number. So we can say x is less than 5. SetBuilder notation, you just plug that inequality in. On the graph, we're saying all of our numbers are to the left of a. So the less than symbol tells us we use a parenthesis. So notice there's a parenthesis at a, because it's less than a. And then we have the arrow going to negative infinity. So when we go to interval notation, what we do is we go left to right. So if we look at our graphed part, the orange, the left part starts at negative infinity. And then we stop shading at 5, or not 5, at a, because it's just any number. If it's a number, you know, if I used an example of 5, but we stop shading at whatever a is. So on the left at negative infinity, that's always going to be a parenthesis, and your parenthesis faces the direction you're shading. So I'm going to have a left parenthesis because we're shading to the right of negative infinity. And then at a, because it's a less than, it's a parenthesis, and it faces where you're shading. So our shading is to the left, so then it's a right parenthesis because it's opening and looking to the left. And that's how we write interval notation. So it looks sort of like an ordered pair, because you've got something comma something else with parentheses. The key of knowing whether it's an ordered pair or not is to know the context. Are you doing something with inequalities, or are you graphing? So let's go to the next one where our inequality is x is less than or equal to a. The only difference here, is our symbol from a less than to a less than or equal to. And the only difference on the graph is what we have at a. We had a parenthesis and now we are at a bracket. What that means is the only difference here is that our parenthesis at a is going to turn into a bracket. So this gets written as negative infinity to a, and then we have a bracket symbol instead of a parenthesis. Now, the third row, we've got x is greater than a, so we're saying our value is greater than whatever a is. And so you notice that on our graph, we're now to the right, because now we're in the bigger numbers. Our answer is larger, so we have to go to the right towards positive infinity. So when we read interval notation, when we write our interval notation, we always go left to right. So the left part where we start shading is at a, and then we shade all the way until we hit infinity. So I'm going to have a first and then infinity. And then at a, it's a parenthesis because it's a greater than symbol. And then at the right, when we hit infinity, infinity always has a parenthesis. And notice, again, it faces towards where you're shading. So the left parenthesis faces to the right because we're shading to the right. The right parenthesis faces to the left because we're shading to the left. And then the fourth line, the only difference is this: we're switching the greater than symbol to a greater than or equal to. So the only change is that the parenthesis at a changes to a bracket because the symbol with a changed from a greater than to a greater than or equal to. Next, we've got compound inequalities. So there's basically 4 different combinations of compound inequalities where we're saying that our value is in between these two things. So the first one, we have a is less than x is less than b. This is saying that x is between a and b. And so on our graph, our solution is between a and b. So I've got a and b on the graph, and then we've shaded in between there. Because they both have less than symbols, they both have parentheses. And notice the parentheses are facing where the shading is. So when we translate this in an interval notation, we always read left to right. So I start shading at A. I stopped shading at B. At A, I have a less than symbol, and that's a parenthesis to the right because we're shading to the right. At B, it's another less than symbol, so that's a parenthesis, but it's going the other way because we're shading to the left. Now the next line, we've got a is less than x, less than or equal to b. So the only change between these two is the symbol with b. And so you can see on the graph, the only thing that changed was the symbol at b. It changed from a parenthesis to a bracket because a bracket always has the less than or equal to. So what that means for our interval notation is that the symbol at b is going to change, but the rest of it will be the same. So parenthesis, a comma b, and then it's a bracket. Then after that, we have a change. Now it's the difference between the a less than or equal to x, less than or equal to b, and the one above it is just on the left side. The right side's the same. So notice that we had to change the symbol at a because the inequality symbol changed. So now for my interval notation, instead of a parenthesis, it's a bracket because it's a less than or equal to symbol. But everything stayed the same. So we ended up with 2 less than or equal to symbols. So that's why we have 2 brackets. So both of them have brackets. And then on the last one, we've changed from the less than or equal to on the right. Maybe instead of, let's use orange. We had a less than or equal to with the b. We've now changed that to a less than. So now the symbol at b had to change to a parenthesis because less than always has a parenthesis. So on our interval notation, that bracket is going to turn into a parenthesis, but we still have a bracket at A because A has a less than or equal to sign. So now I've just completed this chart. So I'm going to erase my little highlights here so it doesn't mess up when you like print out or copy down the chart. Let's see if I can neatly delete these without getting rid of my graphs. So this chart I would definitely have handy because you can use it as a reference. When you're solving or when you're figuring out, you know, what you've got your inequality on the left, and then you just go to the right and read, okay, what does the SetBuilder notation look like? What does the graph look like? What does the interval notation look like? And so this is going to be very, very handy for your notes as a reference. Now, there are two special cases where you may have no solution or all real numbers where every number is a solution. So no solution, your graph is empty because there is no value on your graph where you have the solution. For all real numbers, your graph is completely filled in, completely shaded because every number is a solution. So the special cases for these is when we have SetBuilder notation, we usually will instead use set notation. So no solution usually will be an empty circle, or you can have what's called the empty set. So we've got a circle with a line that also means empty set, or the curly braces with nothing inside. And we don't really have an interval notation. We will basically use that empty set circle. So maybe actually what I should do, let's put the SetBuilder notation as just the empty braces. And then interval notation is basically a 0 with a slash through it. And that means empty set means there's no answer, no solution. So our set of solutions is empty. Now, for all real numbers, everything is just a solution. So in SetBuilder, we have our curly brace. We have X, the vertical bar, and then we'll say X is a real number. And I'm kind of running out of room here. And then you kind of empty you close your brace. So that's how we show that every answer works. And in interval notation, our left part of the shading is at negative infinity, which infinity always has a parenthesis. We stop shading at positive infinity, and infinity has a parenthesis. So that's what it looks like in interval notation. You're going from negative infinity to positive infinity, and then you have parentheses because infinity always has parentheses. So this is another thing that you're going to want to put in your notes to reference so that you know how to write these solutions. So now we're just going to go into lots of examples to kind of work it out. I wanted to make sure that I have the charts for you first, and then we're actually going to do some graphing, because I recommend graphing before you get interval notation because it just makes it easier. So we've got our curly brace, so that's the set of X, or all X, and then where X is greater than or equal to 6. So what we are given here is SetBuilder notation. So the first thing we want to do is graph it, because I always recommend graphing and then doing interval notation. So on my number line here, I always start by labeling where negative infinity and positive infinity are. And those just represent that we go on forever. Towards negative numbers go on forever, positive numbers go on forever. And then the number that I have in my inequality, 6, I'm going to put on the graph. And it doesn't matter where, so I'm going to just label 6. I'm going to just put it somewhere. When you're in Connect Math, they'll actually have like an actual number line with all the numbers listed, so you just have to know where your thing is. So we have x is greater than or equal to 6. So greater than 6 means that we're to the right because that's where the bigger numbers are. So that's where I want to shade. Did I not pick a good? Just try to. There we go. I was trying to shade it. So I'm going to kind of color in to the right, and then I go all the way until I hit the end, which is at the arrow. And then I go back to the symbol. So it says greater than or equal to. So that equal to means I'm going to have a bracket. So that's telling me bracket. And it faces where I've shaded. So that means my bracket is going to be facing to the right. So that's going to be my graph. Now, when you put this in Connect Math, they want you to put the bracket symbol first, and then you do the shading. So in Connect Math, you do your symbol first, and then shade, because otherwise it will, if you do your shading first, it will shade everything. So you just have to do it in that order. I always do it on paper first, and then once you've got it on paper, then you can make sure that's the order that you do. But that's how they want you to enter it in. So you pick your symbol, put it at 6, and then there will be a button for shading, and you click that, and you click which part of the number line you want to shade, and then it will just shade it for you. So now that we've got our graph, this we put in an interval notation. So at 6 on the left, we start shading at 6. So I'm going to start with the number 6, and then I stop shading at infinity. And then 6, I have this bracket symbol, so I'm going to put a bracket at 6. And then just know that infinity always has a parenthesis, and so it's going to be facing inside because it kind of faces, you know, towards the shading. And that's your answer in interval notation. So it's like you're just reading your graph from left to right. We have 6, we have a bracket at 6, and then we stop shading at infinity, and infinity has a parenthesis. So always has parenthesis. Has a parenthesis. So that's how we get our interval notation. And so we started with SetBuilder notation and we converted it to interval notation. Now, we could also use that chart that I have. So our interval notation, our SetBuilder notation, we had that were greater than or equal to 6. So we were right here. We were given something that looked like this, but with the number 6. So if you're using this chart, then all you need to do is go over and say, oh, that's what my interval notation looks like. And you just replace A with that number, or 6, and then that's your answer. So you can use this chart. You just have to figure out what number is representing A, and then you just kind of plug it in. And you've already got the right form, and it shows you the graph as well. So that's just, you know, how you can use this chart to save yourself some time. If you know, you can, instead of like going through and thinking about all this, you can just look at the chart and then say, okay, well, what does this chart tell me I do? This is what I've got. Are there any questions? Okay. So here's another one. We've got, again, this is SetBuilder notation that we're being given. So you always recognize SetBuilder notation by the fact that you've got these curly braces and you've got this vertical bar thing with your variable to the left. So this is saying that we have the set of all x where 1/2 is less than x, and x is less than or equal to 4. This is telling us that our answer is between 1/2 and 4, basically. So I'm going to start by graphing, and I'm going to put my negative infinity and positive infinity on my number line. And then I need to have both 1/2 and 4, because those are the two numbers that I'm given here. So it doesn't matter where I put them, just as long as you have it in numerical order, smaller number on the left. And so now I'm going to do the shading. So we have our x in between these two numbers in our inequality, so that means our solution is in between these two numbers. So I shade in between. Now I need to figure out what my symbols are. So at 1/2, I have a less than, which always goes to parentheses. And it's going to face where I'm shading, so I'm going to use the left one. And then at 4, there's a less than or equal to, which is always a bracket. And so I'm going to have a bracket facing the shading. And then that's my graph. So in Connect Math, what you have to do is you have to put both symbols in first before you do the shading. So you have to make sure you've got the parenthesis there and the bracket there, and then you click to do the shading. So now we're going to put this in interval notation. And so I'm going to start at the left, where I start shading is at 1/2, and I stop shading at 4. And then you basically just copy your symbols. At 1/2, I have a parenthesis. At 4, I have a bracket. And so I just copy those symbols down. And that's your interval notation. So if I go back to that chart, we've got our SetBuilder notation where we have a less than and then a bracket. So we are right there with our SetBuilder notation. And so you can see the graph looks like what we have, and then our answer, we have a parenthesis and then the bracket. So you can just kind of read what you've got on the left, and in this case, your two numbers are A and B. So you need to figure out, well, what number is A, what number is B, and then you just plug them in and replace A and B with those numbers. So it's like you're just comparing it to what you're given, and then you plug it in, and that gets you your solution. Are there any questions? Okay, so let's do something a little different. Yeah, it is pretty straightforward. It's just a matter of, you know, being able to read your chart and then going from there. This is where it starts to get a little bit tricky. So, but it's really not that bad. So we've got this graph here. And so we've got at 3/4 a parenthesis, and then we're shading to the right. And first thing it says is to write in SetBuilder notation. Yeah, don't knock on wood. It gets more difficult as it goes, but it's still not that bad. It really isn't. So what I do with something like this is we've got this graph, and then it says to write in SetBuilder notation, is I'll set up my SetBuilder notation. And, we assume we're going to use the letter X. So I just kind of set it up where I've got my curly brace, my variable, my vertical bar, and then I'm going to leave a gap where I figure out my inequality, and then I'm going to close my curly brace. So now I look at what's going on. So we are shading all the numbers to the right, which means it's going to be greater than or greater than and equal to. So I'm going to just put the greater than symbol. And it's a parenthesis, which means that it's a greater than. So I'm not going to put the line underneath. I see, okay, that's a parenthesis, so that's a greater than. So I'm going to kind of put that in the middle. And now we always read these left to right. So when you have one thing, it's always x is greater than. So I know that x has to go right here. And then that means my number goes in the missing spot. So our inequality here is x is greater than 3/4. And now I've finished my SetBuilder notation. Next is interval notation. So I just look at my graph here. So I'm starting at 3/4 and I have a parenthesis. And then I don't have, I don't have parenthesis or infinity labeled, but you can put that in. We're shading all the way to the end, which is infinity. And that always has a parenthesis. So then I can do my interval notation, where we've got parentheses on both ends and we've got 3/4 to infinity. Now, if we go back to that chart that I had, you can use the chart, but you're looking for where graph looks like what I have. So this graph looks like what we were given. And so that tells you, if you go to the left, you go to, okay, what's A? A was 3/4, so then you just plug it into your SetBuilder notation. You replace A with the number. And then your interval notation, you just replace A with a number. So with this chart here, you just look like, okay, where do I have a matching shading? And then I just go to the left for SetBuilder notation and to the right for interval, and you just have to figure out what number you're replacing. So not too bad. It's just, you've got to look at it a little bit differently. So there are questions here? Okay. Now let's take a look at this graph. So here we've got our graph where we're shaded between -1 and 8, and then we've got parentheses on both sides. So we're going to start by writing in SetBuilder notation. So I'm going to just set that up first. Curly brace, X, bar, and then space, and then my closing my curly brace. And on the keyboard, the curly brace is above the brackets near the letter P. It's shift, and then it'll get you that curly brace. So in this case, we've got two numbers. So what this means is that we're going to have two inequality symbols, and we're going to have X in the middle. So when I'm writing my inequality, I know that X is going to be in the middle. And then I've got my numbers on the basically in the order that you see them, -1 and then 8. And then you look at your symbols. We have parentheses at both of these things. And it's always going to be parenthesis, means it's a less than or greater than, but we don't use greater than symbols in the compound. So it's always going to be a less than symbol. So parenthesis is less than or greater than, but compound always uses the less than. And compound inequalities where you have two pieces. So the compound inequality will only use the less than symbol. Unlike if you have just one number, it could be either one. You have to determine, am I shading to the right or the left? But compound only uses the less than. Or it might use a less than or equal to. So that kind of tells you, well, which symbol do I use? And then you use it in both places where you have the parentheses. So it's a little harder to do the SetBuilder notation here. Because it's like you have to kind of, well, you're like, well, I've got parentheses, but the direction the parentheses go does not tell you which inequality you use. You have to kind of look at what we've got. But interval notation is easy because it just comes off of the graph. We have a parenthesis at -1, we shade, and then we hit 8, and then we have our parentheses. So interval notation is really easy when you're given a graph. It's SetBuilder here that's a little tricky. So this might be one where you really want to use your chart. So if I go back to that chart, we're looking at this situation right here, where we're in between and we've got a parenthesis on each side. And so it might be easier for you to then just figure out, okay, what's the number on the left, the number on the right, and then plug them in for A and B in your SetBuilder notation. Less thinking if you have the chart handy, you just look at your chart, plug in your numbers. Interval notation then you can get on the right, which is not bad from the graph. But the SetBuilder is a little tricky here. And the SetBuilder for all of these compound inequalities is tricky. So you may want to use this chart to figure out your SetBuilder notation instead of trying to think it through, because it's a little harder when you think it through, because it takes more thought. So, you know, this chart is handy. You just look at the chart, replace the numbers really fast. You know, if you've got a problem like this on a quiz, if you got that chart handy, it should take you less than like 2 minutes, because you're just literally looking for what you've got on the chart, plug in the numbers. So I'll erase that so you guys can print that chart out. Are there any questions here? Okay, so let's now, you know, do something a little different, because you need to be able to go between all of these different forms. So we've looked at given SetBuilder notation, find the other two, given a graph, find the other two. Now we're given interval notation. And we want, whoops, help if I spell right. We're given interval notation. Then we're going to graph and put it in SetBuilder notation. So the graphing part is not hard. Actually, this is why I like interval notation, because it's really easy to go from graphing to interval and interval to graphing. So we've got 18, so I just put 18 on my graph. I'm going to label my negative infinity and then positive infinity. And because our interval has 18 to infinity, that tells me I'm shading in between 18 and infinity. So that's nice, because it's just, oh, it's like, okay, that's where you're shading. And then I've got a bracket at 18, so I just kind of copy that bracket down. So it's really nice to go from interval notation to a graph. Now we want to go to SetBuilder notation, and again, this is kind of tricky. Doing SetBuilder from interval, I always find it helpful to look at the graph. So I always find it helpful to graph it and then think about what I'm doing. So SetBuilder notation, I'm going to put in my kind of chart. You're not really the chart, but I'm going to put in what we've got and then fill it in. We've got your curly brace, X, vertical bar, and then your gap where you're going to put your inequality, and then you're ending your curly brace. So if I've got one number listed here, instead of two numbers like the compound, you have two numbers. Here we've got one number. So one number means that you're always going to have X and then the number, and you just have to figure out what the symbol is. So here we've got shading to the right, we're greater, and then because it's a bracket, it's greater than or equal to, because we can include that endpoint. So that bracket, because it's shading to the right, that's telling us we're going to have a greater than or equal to. So this gives me my SetBuilder notation. But I think it would be a lot easier for most people to use the chart. So just remember what we're given here for interval notation. We've got a bracket, a number, parenthesis, at infinity. So I'm going to go to the chart and then look for that bracket, number, and then infinity. So that puts me right here. And then, you know, you can see, okay, that matches the graph that we had. And I think what will make this really easy is then you just have to go over to your SetBuilder notation so you know how to write it. So if you're given interval notation, and you need to find SetBuilder, I really recommend using this chart because it's a lot easier to convert it from one to the other using the chart. There's less thinking because it does take some thinking through if you try to do it otherwise without the chart. So you can see this then matches what we did. We had the greater than or equal to symbol at 18. But I do recommend, given an interval notation, use the chart versus trying to figure out the SetBuilder. Graphing it is not bad. You just kind of read the graph off of your interval notation, so that's not hard. But you can use this chart to get your graph as well. But the SetBuilder, that's the tricky part. Any questions? Okay, so here's another one. We've got interval notation again, and I can tell because I've got these brackets. And so we've got, this is basically telling us we're between -10 and -2. So when I'm graphing, I'm going to put in my negative infinity, positive infinity in my number line, and then I just need to put in my numbers. -10, -2. And then I'm between these two numbers. That's where it's saying, like, whenever you're reading the interval notation, it's saying you're shading between those two things. So I'm shading between these two numbers. And then they both have brackets, so I just literally copy those brackets down. Which is really, really nice. Now, just as a side note, that if you're given a problem and it doesn't have brackets, but it has closed or open circles, this would be closed. So sometimes you might get a problem where instead of brackets, you're asked to put closed dots. And you still put the dots first and then shade, but they mean the same thing. So you could have closed circles to represent this, or you would have brackets. And actually, I should go back here. Sometimes, if the bracket symbol isn't given, this would also be a closed dot. Let me see if I've got one. So here where we're given a parenthesis, sometimes instead of a parenthesis, it's an open circle like this. So just be aware that sometimes, depending on the type of question, we kind of use them interchangeably. Instead of parentheses and brackets, you'll be given open circles and closed circles. So a parenthesis is the same as an open circle. Bracket is the same as a closed circle. Most of the time we use the parentheses and brackets, but just kind of side note there. So back to here. Let me erase my little circles, because we usually use the bracket there. So that's graphing, easy enough. Next is SetBuilder notation. So I'm going to do my curly brace, X, vertical bar, gap. So now I've got two numbers, which tells me my X is always in the middle. And let me actually change that color back to the orange. So I'm trying to figure out my inequality. And then I've got -10 and -2 on either side of this X. So this is a compound inequality. And so when we've got a compound inequality, the brackets, either bracket, they always go to less than or equal to, but only for compound inequalities. So I'm going to replace these with less than or equal to symbols there. So if we go back to the chart, it's a lot easier to just kind of go to the chart here. This is the graph that we had. This is what we were given, something in with brackets on either side and two numbers, -10, -2. So those are your A and your B. So it'd just be a lot easier to go back to your chart here, and then you just replace your A and B with -10 and -2, and all the symbols are there for you, and you don't have to really do any thinking. So I would recommend definitely when you've got this interval notation and you're asked to do SetBuilder or SetBuilder to interval, I would definitely use this chart. It's really nice. So I'm going to erase those, go back to here. So any questions on this one? Yeah, it's not too bad. I mean, it does take some thinking, but really print this thing out. Print it out, copy it down, whatever you need to do. I think even on the homework, we might have a link before you open up a homework. There might be a link to an attachment of something like this that you can download. But if you have this handy, especially like on your quiz for this week, you have this handy, all you have to do is look at the chart, and it doesn't take that long at all. It's just a matter of reading the chart. And these other two special cases, those are going to be kind of rare, so you won't be like dealing with those too much, but it is good to be aware of these. You'll see these more really when you're getting into college algebra, but most of the time what you're going to be dealing with is, I can get my thing to go back, this kind of thing. So it's like, just print this out, copy it down, whatever you need to do, and then make sure that's handy when you're doing your quiz. So that was all I've got. Was just examples of going between these different things. I do have another video that's entirely on graphing, and it also kind of covers the SetBuilder notation and interval notation. So if you need more practice with that, you can do that. But it's basically the same as kind of what we did, just in different orders. And I got something in my eye. This is the last live, of course, for the week, because it's week 8. So you guys don't have a final exam, you just have a quiz, because your two exams were kind of like the midterm and final, but at different weeks. So like weeks 7 and 8 are kind of prepping you for college algebra. So we're just having quizzes this week. So it's just a quiz, just an hour long. But you do have to make sure that, because there's no late work once the course closes. So on Tuesday, the course will close at 11:59 p.m. Once that deadline hits, it shuts everything down. You'll be, if you're in the middle of a quiz, it's going to submit the quiz. You cannot submit anything to Blackboard after that. It's just done. So make sure that you take your quiz early enough that you get your hour and you have time to submit your quiz work so that you can get that turned in, because if you wait too long, you're not going to have time, and then we can't accept anything via email. It has to be submitted via Blackboard. It's just part of our requirements for accreditation and assessment and everything, that everything has to be in the system for it to count. So just heads up, Tuesday, don't wait till the last minute. Make sure you start early enough that you have time to submit everything. And you can go back and redo any homeworks if you want to increase your scores. That's just the last time to get everything in. So if you have any missing quiz works, get missing quiz works in. Yeah, homeworks have unlimited attempts, so you can always make those higher scores. So that's it. That's all I've got. If you're taking college algebra next term, I'll see you next term. Otherwise, I may see you again. If you have other math classes, maybe not. We'll see. But I really enjoyed doing these lives. I'm glad that you've attended that. I'm glad that I've had people attend every week. That's always really good. So any last minute questions while you've got me here about maybe the end of the course or anything like that? Nope, just that you'll see me next class, so great. We do have a week off between terms, which is wonderful. I love when we have a week off, so that's really nice. I recommend using that preview week to kind of plan out your time, figure out, your whole schedule for the next 2 months so that you can get your time management going. But yeah, so all right, well, I will let you go to the rest of your Saturday. I'm going to go probably eat, because I didn't eat lunch yet because I woke up late. And then I'm going to watch some Olympics because I'm a huge fan of Olympics. So that's what I'm going to do. So All right. Take care. I'll see you at next class, next term. Bye. Take care.